All right, last but not least, we have the last section, which is 9.12, and this one is a function and the inverse of a different function. Okay, so this one we're going to have all these go ahead and get mixed up. So step one is, if possible, go ahead and evaluate the inside, so that inverse function, and then evaluate the outside, which is just our normal trig functions. Okay, and then we know that we can go ahead and draw a triangle in the correct quadrant, and then you guys can go ahead and use what you know about SOHCAHTOA, semi-opposite adjacent hypotenuse, to go and solve for the trig function. Okay. And with this, right, we know our Pythagorean triples. We have to go ahead and recall them. The first one we all know is 3, 4, 5. Second one is 5, 12, 13, 7, 24, 25, 8, 15, 17, and then 9, 40, 41. And the list goes on and on. But these are like the most common 5. Okay. So the first one, right, we see we have a sine of the inverse cosine function of 3/5. So in other words, we have to go ahead and find the sine of the angle whose cosine is 3/5. So I'm going to go ahead and use SOHCAHTOA. I'm going to go ahead and we are focusing on my inverse function of cosine of 3/5, right? In this one, cosine is in quadrants 1 and 2, so it's positive, so we are going to be living in quadrant 1. So there's my triangle. Let's say that this is my theta. So then cosine is, 3/5, and that gives me my 4. That takes away this part, so all I'm doing is just evaluating sine of theta, and that gives me 4/5. So your answer is going to be 4/5. And again, we are in quadrant 1. And that's it. Okay, so like in example A, right, it says sine of the tangent inverse of -1. Right, tangent is only in quadrant 1 and 4. Since it's negative, we're going to be in quadrant 4. So if I draw my triangle, I'm going to be in quadrant 4. There's my theta. Tangent is -1. So opposite is -1, adjacent is 1. You could go ahead and do a Pythagorean theorem. Yeah, let's actually go ahead and do that. Right, so we get s squared is equal to 2, so then we get x is equal to the square root of 2. Now, it would be technically plus or minus 2, but your hypotenuse is always a positive value. Okay, so that takes away my tangent inverse of -1. So all I'm going to go ahead and calculate is sine of theta, which is -1 over radical 2. And again, we cannot forget that we have to go ahead and rationalize my answers. So we get negative radical 2 over 2. And that is your answer. Okay, I'm going to go ahead and skip B. You guys can go ahead and do that. Let's look at some of the other examples. We'll just go ahead and do D, F, and H. Let's go and do that. All right, part D, it says tangent of sine inverse of a negative radical 3/2. Again, sine is either between quadrant 1 and quadrant 4, so this is going to be in quadrant 4 because it's negative. I'm going to go and draw out my triangle. Okay, there's my theta. Sine is a negative radical 3/2. So then we get 1 over here. Again, you can go into Pythagorean theorem, but this is also how we figured out our coordinate planes of our unit circle. And again, all I'm evaluating is just tangent of theta, so opposite over my adjacent. This becomes negative radical 3. Okay. F is a little bit different, right? We see that we have that secant value. But again, first we're going to go ahead and calculate the arc cosine of a -2/3. Right, cosine is either between quadrants 1 and 2, so it is negative, so we are going to be in quadrant 2 to start out. There's my theta, so cosine is a -2, 3. Okay, this one I actually do have to do the Pythagorean theorem. Oops. So then we get x is equal to radical 5. And secant, right, we know that cosine is its inverse, so cosine is adjacent over hypotenuse. Secant is just this, but flipped. So we're going to be calculating the hypotenuse over the adjacent. So that is going to be 3 over negative 2. So my answer is 3/2, so negative 3/2. Okay. And the last one we'll go ahead and do together is part H, where we're talking about sine of the arc cotangent of 4/3. Again, we have to go ahead and evaluate this guy right here. Cotangent is just the inverse of tangent, so we got to think of in terms of tangent. Okay, so this one, right, since it's a positive 4/3, we're going to be in quadrant 1 if we're thinking of tangent. So quadrant 1, here we go. Now we know that tangent is opposite over adjacent, so that means cotangent is adjacent over opposite. So this is where our 4/3 come from. Adjacent is 4, opposite is 3, so then my hypotenuse is 5. And again, now all we're evaluating is the sine of theta, which is just 3/5, and that is your answer. Okay, so when we're doing these problems, you really want to make sure that your guys are focusing on the 3 domains for our inverse functions. So again, sine inverse, we're in quadrants 1 and quadrant 4. For cosine inverse, we are in quadrant 1 and quadrant 2. And then tangent inverse, we're in quadrant 1 and quadrant 4. Okay. You can do the example.